Welcome to another episode of Xah Talk Show. And today I'm gonna talk about Emacs, lots of Emacs stuff. So the topic today is going to be Emacs demo, xah-move-image-file, and Emacs Lisp. Okay, I'm gonna do xah-move-image-file. I'm gonna demonstrate that. Then there are several other topics. Now, which one topics we gonna go into depends on you. So you just type in the chat box and we can talk about that topic. Now let me get the browser ready. Let me pop the chat out, and okay. So let's begin then. Let's begin in the beginning. So xah-move-image-file. So I'm gonna do a demo of this Emacs command I have. And first of all, okay, so let's show xah start command log mod. Now this window, as you know, it will show all the commands I type in Emacs. So if you see something I'm doing, you can look what command it is. So okay, so let's start with the keyboard. So I have this page. I need to start the browsers. Okay, start the Brave browser, and I have this page about keyboard. Now I'm going to show you a Emacs command so if you write blogs, you are going to do a lot of screen captures. Possibly I do, because for example I need to capture this image, and sometimes you need to capture Twitter images, or whatever. But for now I'm going to capture this image. So let's open it. Okay, turn on the JavaScript script allowed. Okay, so let's look at the image. Hopefully, oh, this is actually a video. Oh shit, I don't want video. Okay, so we don't want video. Let's stop the JavaScript then. Okay, so I'm going to just click that, open image in a new tab. Okay, that's what I want. Now let's save it. Now I'm going to save it with with a file name in my downloads folder, starting with EE. So this is going to be saved into my download folder. So I do that. Okay, it's saved. Close it. Back to Emacs. And let's go to my keyboard blog. You can see in browser, this is my keyboard blog. And I'm going to go here, add a new section, and then now I want to add the image. Now normally what you do is that you go to the download folder, then you copy the file path, and it's tedious. Let me just show you. So I call this command xah-move-image-file, and it asks me what directory. I'll just say I, and you see this file name is already here. This file name is actually in the download directory. So let's just say enter. Okay, and show in browser. It's like that because it is actually a this is not a normal image file. This is some kind of WebM. Yeah, okay, that's a failure. Okay, so let's do another one then. Let's see how many people are watching. 5 people. Way, yay! Say hi, guys. Say hi here. So this image file. Let's just use another image. Okay. Let's go to xah Wordy. Okay, this is my English and Literature and Linguistics blog. So there's this xah Wordy page. You go to Wordy blog, and you can see Kazakhstan. national anthem. Now, this country, Kazakhstan, you you almost never hear it in U.S. news. But anyway, it's like near Russia, Russian culture, and it looks like it's a great country, and they have a great national anthem actually. But anyway, our job is to save an image, okay, to demo this image. So let me show you. Let's copy that. Go to a new tab, paste it. We want to go to Wikipedia. Hi, Green Deck. Hey, Green Deck, have you ever been to Kazakhstan? Hey, Isaac. So Kazakhstan, we are going to demo, Emacs. Oops, shit. Okay, so let's magnify, go down, and go down, go down, go down, go down, go down. There is a shit. There is some beautiful pictures of the city that, okay, let's open that one. And okay, this is taking more time than I wanted to. Sorry about that. But okay, here. This is the picture I want. Let me show you. So this is a great architecture photo. Let's open that. Some kind of art museum or art library. So we want. Let me demonstrate this, and let me answer the questions. This will be quick. So I'm gonna save this file. Again, start with EE. Okay, the file name must start with EE. Okay, save it. Then I go to okay, let's go to xah-arts. Actually, open xah-arts. Okay, now xah-arts is my one of my website, and which contains many architectural photos. For example, architectural beauties. I kind of collect them. Okay, something is wrong. Why is that everything I tried to do some demo, something went wrong? You see, this is not correctly formatted. Some CSS is not loading or something. Reload. I don't. Okay, but anyway, this page collects architectural photos. So actually, I want to add a page to here. So let's go to xah-arts. Okay. Whoops. Art blog. Okay, this is my art blog. It contains randomish funny or beautiful art stuff. So I'm going to add the page here for now. So go to here, add a new section. Then I'm going to call xah-move-image-file. Okay, where do I want to move it to? To the directory I. Okay, press enter, and it asks me your name. You see here, Palace of Arts Shabit, something like that. Okay, enter. So now it's added. Now look at the. You see, that is the command. Now that is the command xah. Where did I call it here? xah-move-image file here. You can see it's this one. So what it does is that whenever you do a screenshot, it will also work on for screenshot. For example, let's for example, let's say I want to do a screenshot. Let's say this. Okay. Now it's screenshot. Screenshot is also usually saved in some like on the Mac. It's usually you can control where it saves, but on the Mac I think it's saved to desktop or something. But now look, I'm gonna call that command again. So new directory, xah-move-image file. It asks me where do I want to save it. Let's say okay, and the name is by default is screenshot. Let's say yes. Okay, then it's automatically, when it's PNG file, it automatically calls opti-png, which reduces the image file. So anyway, you can see it's here. Now let's view in browser. You see, so this command is very super convenient because you don't have to go to the whatever the directory to find the file. Then you try to move it to the directory of your blog. Then you try to add the image tag to it. All of these are done just with one command, or two keys. I have it set to two keys. So you see, it's very good. Now we don't need these image files. Let's open it, delete it. Now delete that, delete that. Wait. Yeah, delete. Show in browser. This image I want, but this image actually I want to put it in the architecture. Wait. Geodesic Doom. Yeah, architectural beauties. Okay, obviously something is wrong here. I don't. Let's fix it. Let's try to fix it, shall we? So open. You see, okay. So I have just demonstrated xah-move-image-file. Now let me show you another thing. So this is a local file. The URL you can see at the top. So I copy the URL. Go to Emacs. And I want to open that local file, so I can just do this command. Look at the left panel. It's opened. So that command is xah-open-file-from-clipboard. And you can see if I this is the path of the file I just opened. Including the URL prefix file, a colon // so that command will take care of that. It will just open whatever path URL in the clipboard. So I opened the file. So let's fix this. Somehow it got broken. I think it's probably CSS has something to do with CSS. Okay, let's look at the comments. Green Deck, no, unfortunate. So you haven't been to that country, that Kasa something. This country. Okay, let's this country, Kazakhstan. But I know a couple of people from there. Okay. So Isaac says, I had a question I was thinking about all day that I was going to ask you, but I have unfortunately forgotten it. Okay, that's a good question. Mooch Detten says, hello comrade. Hello comrade. Okay, so the topic meandered into how do you fix, in my daily life of working on my website or programming languages. So now I have this problem. This site is not broken. It shouldn't be like that. So now I need to find out what's going on. So let's just do that then. So xah go to a wait. So first of all, let's check the header. So I got let's magnify header. No, it's not header. Okay, so oh, I know why. Because remember last week, like a week ago or so, I changed, like I was doing a video, I changed this main tag. It used to be this. It used to be like that. Okay, and I changed it to that. And that is why, I'm pretty sure that is why it's broken. we can find out by go to the top, open the CSS file, open it, and search for main list matching lines. Okay, there is none. Okay, so all these pages are okay. Let's search for div. Okay, yeah, here is a problem. No, that's not the problem. So I don't actually know what is going on, and I'm wondering currently whether I should continue to fix this page. So should I continue fixing this page, or should we get into some other interesting topics? You know, I can so these are some topics I was thinking of talking about today. And okay, so let's go back here, and actually today's date, let's get the title correct so that new people come in. Oh, today is 5th. That's correct. No, the title is correct. Okay, so okay, so guys, let me know. Okay, so I want to fix this page. You see, these are all basically, I know what is going on because I'm missing. You see, each one of these, for example, this one, Asian demigoddesses. Now, if you look at browser, that's the first one here. So this block, this block is the first one. And in CSS, it should be set to inline block. Okay, there's a display CSS display property. It should be set to inline block, but that's not happening. That is why you are seeing this kind of things. So display inline block. Okay, so let's go back. Let's go to the CSS again. Search for main. Okay, then okay, I don't know offhand why it's wrong. Yeah, because I'm wondering if I should continue because you know, this might be, you know, take 20 minutes or 10 minutes, then it's a waste time for you guys. So let's just try to add that. So we added a div here, and look in browser. Yeah, so it's missing a div. Okay, for now, let's just put a div then. Let's put it div. So put a div. Yeah, that looks much better. Okay, let's show eShell, powerful eShell, and xah interactive abbrev. Okay, now it's uploaded to my website. So green day. Okay, so if you go back to my website, let's see, xah architecture, and reload, you see now it looks much better. you can maximize the window. Then you'll okay, that's one command. Then that's so what we have shown xah talk show. Scribe key, this key, then you have the command xah-move-image-file. Let's go to the file. Okay, yeah, the URL is here. So if you like to have this command, you can just go to my website and use it. Okay, that's one thing. That's one topic done. So let's see what else. Emacs demo. So the next one is Emacs Lisp. I can do an Emacs Lisp demo of this command, xah copy HTML by link. So if so this is a live talk show, type like which topic you want me to cover, and we do that. So this one, Emacs Lisp, I'm going to demo this command, and this command, there's something else I need to add, I need to modify it. So in the process, you can see how I, work on Emacs Lisp. Then I can explain some Emacs Lisp, stuff like a tutorial, something. So Emacs Unicode, add a Hebrew page. Yeah, we can do that. Emacs Unicode UTF-8 history. Yeah, and introduction to Unicode for programmers. I can talk about that because last few days ago I did that, but I'm not sure it's very good. So we can do that again, and other topics. So any other topics. So how are you guys? Say something. Let me know where to go. Let's see. Go back. 6 people watching. Yeah. Just type something here. Okay. Let me what should we talk about. So Isaac, did you remember what's the thing? Unicode intro. Okay, let's do that. Thank you. So I'm going to give you an introduction to Unicode for programmers. Okay, let's close that. So now I just have one browser, so it should be faster. So let's go to xah Unicode. And you can see Unicode. Okay, this is my Unicode characters page, and my Unicode pages are actually most popular among all my pages. They are like more than 50% of traffic on my website for some reason, because the easiest, the brainless things people like. People like emojis. People like actually the most popular page is these Unicode arrows, because you don't find this information anywhere else. So on this page, I have I have all the Unicode arrows, collected, and in one grouped them in the by style. You don't find this anywhere. I mean, usually if you go, you search other Unicode pages, they are typically they are just typically grouping by the Unicode code point, which is very bad because the arrows are scattered all over the place. So okay, so here's my Unicode page. Once you found it, you can go to the bottom. There's a Unicode for programmers. Now you go there, and you can see these are Unicode books. Now this is the Ken Lunday. He's in California. He's actually, I think, in San Jose, close to where I live. 40 minutes drive. So he wrote the O'Reilly book called CJK. Let's see, Chinese, Vietnamese, Korean, Japanese, CVKJ or something. Book O'Reilly intro. That's an introduction to processing Chinese characters, Japanese, by Unicode. So he wrote that book, and I read that book back in 2000 or 2001. But anyway, so he's got this bunch of Unicode book. He works for Adobe, and oops, let's close that, shrink it. He works for Adobe, but back in 2000, I also read this book. I bought this book, the Unicode Standard version 3. It's pretty thick. It's like this thick, but actually half of the book content is just a list of Chinese characters. But still, so I bought this book, Unicode Standard version 3, back in 2000, and I read pretty much the whole thing, except the table of Chinese characters. That's all just Chinese characters. So anyway, so on this page, Unicode for Programmers, you can, these are all articles about Unicode for programmers. For example, first of all, there's an introduction, Unicode basics, character set, encoding, UTF-8, what is a code point, and things like that. Then I have, for example, let's see. Okay, what encoding do Chinese website use? Best Unicode for font for programmers. Unicode history, UTF history. Yeah, this page I actually added. UTF is created by Rob Pike and Thomas. What's his name? Oh, Marcus Kuhn. Marcus Kuhn passed away, by the way. Marcus Kuhn is also one of the early internet engineer. Xali, and he's also an Emacs user. And one day he wrote a wait, did I confuse him with someone else? I could be confused with him with someone else. Anyway, okay. So Ralph Pike created UTF-8, and he is also he created with another guy, Unix guy, Thomas. Anyone remember what's the name? Anyway, so that's a history. You probably don't. I mean, you want the basics, introduction to Unicode. So we're gonna do that. Then let me see the comments. The question was about dvorak. I remember now. Assuming you used QWERTY before, did your speed increase, or is it simply for comfortable to type? No, speed do not increase. Okay, should let me answer that quickly. Okay, and then let's go back to introduction to Unicode. Okay, xah dvorak. So I have like 5 articles about dvorak. You can learn everything you want to know, all your questions about dvorak here. So dvorak keyboard is it's a efficient layout. But anyway, if you go down, all the way down, there are actually several articles about dvorak. Okay, I answer the questions here. For example, my experience of QWERTY and dvorak. I tell you the story how I learned it. When I learned it in 1994. Will dvorak make you type faster? No, basically no. Period. But it will make you the typing will be much more comfortable. And that's basically it. Yeah, comfortable. So then there's a question: should you? I mean, most people, when they think of dvorak, they think, oh, it will make them type faster. No, not really. If you already type QWERTY, you won't type faster. In fact, your speed will probably be slower than when you were typing QWERTY, at least for the first year. But if you do not touch type, then you try to learn dvorak, and then of course your speed will be much faster, simply because you are now a touch typer. So there's always the question, so should you switch to dvorak? Okay, the other question is, does dvorak prevent repetitive string injury? Not really. Okay, the answer is not really. If you have hand pen, if you have RSI issues, first of all, get a mechanical keyboard, get an ergonomic keyboard, with middle higher than the than the edges, so-called tinted keyboard. Mechanical keys, get an ergonomic keyboard. So if you are using normal keyboard and you think switching to dvorak, it will not, basically it will have no effect on your typing injuries stuff. So the final question is, should you switch to dvorak? It's like yes and no. So I've been using dvorak since 1994. I was QWERTY typist since 1988 also. Okay, so it's a tremendous pain to learn dvorak. It took me 2 months. it, painful 2 months, because every time you type, it's wrong, then you have to figure out where is the key. So it's extremely painful if you already type QWERTY and you want to switch to dvorak. Okay, and once you so yeah, it's painful to switch. So once you learn dvorak, it's good. It's more comfortable. But should you switch? That's up to you actually. So there's, I wouldn't say, yes, everyone should switch, because there are lots of issues with using dvorak. Because you go to the library, you cannot type, because everywhere it's QWERTY. You have to bring your keyboard to work or something like that, or you have to go to the operating system, like go here and switch to dvorak, and little annoyances like that, so it's really up to you. If you are really concerned about efficiency, yes, of course, dvorak is absolutely more efficient than QWERTY. Okay, efficient in the sense your fingers move less, much less. But why does it not help reduce RSI? Because for the causes of RSI, actually there are lots of other things that's more problem that's causing your hand pain. For example, the normal keyboard, you have the pronation, wrist pronation, and ulnar deviation and things like that. So anyways, yeah. So the final question is, it's really up to you. If you are really concerned about, you want the best, elegant system, efficient, then dvorak is good for you. So WebDog, I know WebDog, you tried to learn dvorak, so and you gave up. So WebDog says WebDog says, is there any easy Emacs command to copy kill the output of an interactive command? Kill the output of an interactive command? Like, what do you mean? WebDog says, I spent 2 weeks trying to learn dvorak and gave up. 2 weeks is not enough. You had 2 weeks of pain. You need more pain. Okay, let's go back to Unicode. So Unicode is this, you know what Unicode is. They are characters. So first of all, so okay, you can read this article, but I'm not going to look at the. So this article introduces you what Unicode is, what character set is, what character encoding is, what character set and encoding systems, and what are UTF-8, what are UTF-16. Unicode character set, code point, and oops, let's go back. Code point, and so so you can read this article, but I'm not going to, because usually when I try to read the article, I start to kind of just reading it, which is no good. So let's not look at that. So I'm going to just to explain what Unicode is for a programmer. Okay, first of all, you need a character set. You define a character set. I mean, even before the computing era, you have a character set. What's a character set? For example, English alphabets, A to Z, capital case and lowercase. That's a character set. You kind of need to define it. For English, you may not need to, because there's just 26 alphabets, lowercase and uppercase. Everyone knows that. So you don't need to define it, because everyone know it already. Then you need you have punctuations, period, comma, semicolon, question mark. You need to include that as a character set. Then you also need numbers 1, 2, 3, 4, and parentheses and brackets, so on. So you have the concept of a character set. Now that's one important concept. Okay, why is this important? Because for example, in Chinese, we have 5,000 to 10,000 characters depending on how you count. Like which you need like 3,000 characters to read newspapers, to have a basic understanding of newspapers. So also each character has many variations. Maybe so for Chinese, for example, it's far more important to have a character set, like meaning that the government design and the education department, design a character set, telling you, okay, this is the standard basic set of, let's say, 5,000 characters. Then high school or college can teach this, and so we have some kind of like a standard even before computing. Okay, now and similarly for Spanish, French, Latin-based language or Indian language or Russian, you need a character set. You need government or something standard body design a character set, so you can all agree on what are the characters you have. Now, character set is very important in computing. Also, it becomes essential because if you don't have the standardized character set, then you don't know which character you're talking about. Because right. So for computing, the character set, you need to define a character set. So in the 1960s or 50s, you have a character set called ASCII. Okay, so let's go to hacker code. No, let's go back to Unicode. So let's go to Unicode, and let's go to ASCII. So ASCII is one of the early character set created by USA. It's called American Standardized Character Information something. Let's see, American. I don't have the full name here, but anyway, it's called ASCII. So ASCII. So ASCII, it defines 128 characters. You can see character A, ABC. You have ABC, capital ABC. You have lowercase. Basically, 128 of them. The first one is called null. It's actually not a character. We'll talk about that. So anyway, you have a character set. Then you also need encoding. What does encoding mean? Encoding basically turns a character, let's say capital case A, to a number, assign a integer to it. So A is 65 in ASCII, B is 66, the question mark is 63, for example. So that's encoding. That's what encoding. Well, that's not encoding yet, but anyway, you need to assign a integer as some kind of ID to a character. So each character has a unique ID that identifies it. It's called in Unicode. This is called code point. So this is very important concept. Remember, code point. It's called code point. A code point is a integer that identifies the character in Unicode. Okay, so in ASCII you also have that 65. By the way, ASCII, Unicode, for the ASCII characters, so Unicode contains all the world's characters, including Asian languages, Asian writing systems, and it of course includes all ASCII characters 1 to 128, 127, 0 to 127. And by the way, the code point between ASCII and Unicode is identical, so it remains compatible in that sense. So y, the lowercase y in ASCII is 121. But in the same way in Unicode, the lowercase y is also 121. The code point for the character lowercase y is 121. So okay, So you got a character set, then you got code point. Now you remember this important concept, okay? Character set, code point, which is an integer ID to identify the character. Now also let me remember another thing. Each character are not necessarily visible or like a glyph you can see. For example, a space character, space, you need space, right? In programming, of course, you need space, but it's a character. But yeah, usually you don't call it a character because you cannot see it, but it's required, it's needed. So space is also, we can call it a character. So it has a code point 32. And there are also other invisible characters. For example, tab key. Let's see, tab. Tab, back horizontal tab, this one, okay? For example, tab, when you press tab on the keyboard, that's like a character. It's invisible character. So you have the code point for tab is 9. And in ASCII you got a bunch of others like null character, start of header, line feed. Line feed is used in Unix and Linux systems for like new line. So whenever you see a line feed character, it means a new line. Again, it's an invisible character. So you got this bunch of invisible characters, and some of them are control characters. Like when in terminal, you can press Control D to exit it. For example, let me press Control D. It exit the terminal. Control D is actually one of these this end of transmission character, and it has code point 4. Okay. So you call that's called control character. So anyway, so character set, you have the concept of character set. Then you have a concept of code point, which identify integer correspond to each character set. Okay, now let's talk about encoding. Okay, what is encoding? Encoding is basically computers, CPU chips. They are just electronics. They are basically just 1 and zeros, 1 0 1 1 1 0 0, binary numbers. Why? Because electronics, they are actually just voltages. When it's high it's 1, when it's low it's 0. That's how CPU works. So you need to turn each character into a sequence of 1 and zeros. So how do you do that? Well, you can say one way to do it is that you take the code point of a character. For example, the character 0 is 48. The code point, that's an integer. Then you just use that integer as its binary representation. Whatever 48 is in binary. So that's one way, and that works for ASCII. So that's so ASCII, you see, there are only 128 characters, and each of its code point can be turned into a binary sequence. So 127 is 127 would be 1 1 1 1 1 1 1 1. Yeah, that's all ones. So I'm good with binary numbers. So you see, so what I'm saying here is that for ASCII character set, they can, since there are only 128 of them, they can all be, you can just use a code point and convert it to binary, and that fits 1 byte, 8 bits, 8 binary digits. That works for ASCII. But however, if you have more characters, let's say if you have 200 characters, let's say then you cannot do that because you need more bytes. Then you have the question, is one character just 1 byte, or is one character always 2 bytes, and things like that. So these kind of, all these things is issue of encoding. Okay, so am I doing okay? Am I doing too slow? Am I like talking about things you already know? Or Okay, I'll answer the questions. Keep the comments coming because I don't know if I'm like talking, dragging on, or so on. So remember, um, character set. Okay, that's important. Code point. That's important. Then encoding. Encoding is turning any character into a sequence of ones and zeros. Now that's what encoding is. Okay. Now for ASCII, the encoding of ASCII is very simple. You have a standard. ASCII is a standard. Okay. ASCII defines a character set, defines a code point. It also defines encoding for 128 characters, and it's trivial because you simply turn the character, whatever the code point, into a binary digit. That is its encoding. But now if you have more characters, that's a problem. So in Unicode standard, let's go back to Unicode. Let's go back to Unicode for programmers. Then the first page, Unicode for programmers. Then you go to Unicode basics. Okay, character set. What's character encoding? Then you have so in Unicode, Unicode is a Unicode consortium. The standard body started around 1990, so 1989, something like that. So they define, first of all, they define a character set. So what is their character set? Their character set is basically it contains basically all writing. It's intended to include all writing possible alphabets or writing systems such as Chinese characters in Unicode. So it has like I don't remember how many characters, but anyway, it's the character set is defined. It's designed to for all languages, all human languages, Asian or today. And today, each year, they actually have a new Unicode version. So Unicode 3 is around year 2000. Unicode 4 is around maybe year 2005. But anyway, since about 2014 or so, 2015, they decided to have one new Unicode version every year. So you have a version in 2017. You have Unicode. So you can see here, Unicode 11 came out in 2018. So in 2019 you're gonna have Unicode 12. So in each Unicode version they add more characters. So you can see here in Unicode 11 2018 they added many more characters for many different languages, and also emoji characters and so on. So anyway, so Unicode has a character set. Each year it adds more, so it's a huge number. So yeah, it has right now, as of Unicode 11 2018, it has 137 something characters. Okay, so Unicode, they define character set. Okay, and each year they add more. Okay, so character set, and Unicode define code point for each character. You have a integer that corresponds to that character, identifies it. Okay, and Unicode defines I think around 4 encoding systems to convert a character into binary sequence. So you have UTF-8, that's one of them. You have UTF-16, that's another one. You have UTF-32, that's another one. I think there's another one, or I don't remember. But anyway, you can read my articles, or you can go to Wikipedia. You'll understand, when you read it. So Unicode Consortium defines 3 or more encoding systems. Today, the most popular is UTF-8. Now, why 3 encoding systems? How they differ? Why you need 3 encoding systems? Because okay, let's talk about the simplest one is UTF-32. Now the 32, the word 32 signifies 32 binary digits, 32 bits. which is 4 bytes. 1 byte is 8 bits, so 8 times 4 is 32. Yeah. So UTF-32 is a encoding system such that every character, doesn't matter which character, any character is encoded into 4 bytes and no more and no less. Every character is just 4 bytes. So the advantage of this UTF-32 encoding system is that it's kind of uniform. Every character is just 4 bytes. So it's simpler to sort them. It's simple. But the flaw, I mean the drawback is that it requires more disk space. For example, if you are writing, if your text is mostly English or Latin alphabets, French or Spanish, each character now is 4 bytes. As compared to ASCII, each character is just one byte. So now your file size is like 4 times bigger. So that's a drawback. So UTF-32 is one of the encoding. Then you have UTF-16. Now, so UTF-16 is called variable byte encoding, meaning that for most of the characters, each character takes 2 bytes, 16 bits, 2 bytes. But however, for some characters, it takes 3 or 4 bytes. So it's variable. I mean, it depends on the character. Okay, so it's kind of changes. Like given a character, you have to look up. It may use 1 byte, 2, minimum of 2, or 2 to 4. 2 or 3 or 4 bytes. So that's UTF-16. Now UTF-16 is kind of, it was popular. It was used in Java, Java language standard. The source code is by the language spec. It's supposed to be UTF-16. Okay, it's also used in Windows file system and also used in Macs file system. So it was popular back in 1990s because it was thought that 16 bits is enough. You don't need more characters than 16 bits. So it was thought because you must remember back then all we have is ASCII. We don't have internet like today, and in fact you never see characters from Russia or from China, Japan. Like you don't see it. There's not even much internet. So basically each country, you only see your own languages. There's ASCII, for U.S. Americans. That's yeah, but that's back then. So, but since the internet, the international communication and so on, you start to see all different languages and stuff. And so it turns out you need more than 16 bits. So UTF-16 is kind of less popular today. The most popular is UTF-8 encoding system. Remember, all these are encoding systems, which are they are standardized way to turn sequence of characters into sequence of ones and zeros. Now, so what is UTF-8? UTF-8 is basically ASCII compatible encoding. Okay, that's why it is popular, especially among Linux and Unix people, and also it became the most popular on the web. Now it's ASCII compatible, meaning that if you look at ASCII, so in UTF-8 encoding, if you have let's go back. If you have a character, let's say capital A, which has code point 65 in ASCII, it also has, the code point in Unicode is also 65. But now you want to encode it in binary. All you do is turn 65 into, binary digits. And in UTF-8, it's the same thing, exact same thing. It's also, 65 in binary digits. So UTF-8 is ASCII compatible in that sense. Um, and it is also a variable encoding system. That means for some characters it takes 1 byte. For some other characters it may take 2 or 3 or 4. So each character takes 1 to 4 bytes. So that is UTF-8, and that is the most popular today. It's used by like 92% of the web today. So let's go back to. So I think okay. There's one more thing I want to talk about, and that's about it for introduction of Unicode to programmers. So let's see. So anyway, UTF-8 is most popular today. It's kind of a standard for the web, and it's used by something like 94% of all websites. Okay, one more thing about UTF, about Unicode. Then let's read the comments. Okay, so you know what's a character encoding, and you know what is a character set and encoding systems. Unicode character set encoding systems, Unicode character set, code point. Okay, we know what is a code point. Ah, shit. That's a code point. Okay. Okay. So code point is the ID for each character. Now there's another concept called character name. Now Unicode also assign a name to each and every character. So, and the name is, so you can see I show a several bunch of characters and I show you their name. So this one, capital A, is called the Unicode name, the character name, is called Latin capital letter A. Okay, and this alpha, Greek alpha, is called Greek small letter alpha. And this Cyrillic character, so this Cyrillic character, this one I need to ask Green Deck. So how do you pronounce this character? So this character is called Cyrillic capital letter Z. Okay, so it's Z. So each character's got the name, and the name is supposed to be unique. I mean, in the sense that given a name that uniquely points to one character, but however, some characters has more than one name, because back in Unicode version 2, they changed some characters' names. So for some characters, you have 2 names. One is old name, the other one is new name. But still, given a Unicode character name, that always uniquely points to one character and one only. That's by design. Okay, so you got code point, you got name. So okay, so for example, Unicode has a standard notation to denote a character. For example, this A. So you got a Unicode name, then you got this U plus 41. Now that is a standard notation for this character. So what does U plus 41 means? That means the hexadecimal for this character is 41, and which is the hexadecimal for the code point of this character. So remember, each character has a code point, which is integer. Now you rewrite that integer in hexadecimal notation, then you add U plus to it. That is the standard notation for the Unicode character. So that is it. Yeah, so that is basically it about Unicode. That's basically what you need to know. That's the essential basic information about Unicode. You understand character set, you understand encoding, what does encoding means, and decoding is the reverse. Decoding is taking a sequence of binary digits, turn it into characters. So you have character set. Different country have different character set, but Unicode defines one character set for the Unicode. So encoding systems, you have lots of encoding systems. Unicode defines 3: UTF-8, UTF-16, UTF-32. And there are several other encoding systems. There are ones designed for Chinese, there are ones designed for Japanese. Before Unicode becomes the standard. So you have encoding standard systems. You have code point and you have character name. So that's the basics about Unicode. Okay, so that's it. Like when you like Python 2 to Python 3, Python 3 was created because they want to fix the Unicode in Python, because before a string is just a byte, which is good for ASCII. But now if you go beyond ASCII characters, each character may have 2 or more bytes. So that's why Python 3 wants to fix that. So in Python 3, each string is a Unicode character. Anyway, so that's how it ties to because encoding, the coding systems, encoding, and these concepts are actually very critical. It's in fact fundamental in computing. Doesn't matter what you do, programming languages, internet protocols, TCP/IP. It all has to do with encoding, because when you have a writing system, English for example, you need to convert to a sequence of bits. So it's it's all important. As a programmer, if you just started programming, you may not be very familiar, but as you get more experience, you'll see more encoding issues. In fact, it's a good thing to actually understand the ASCII well. You have to take a look, read the article, because for example this oops, let me go back. This Stack Overflow error page, they showed you this, but now if you read this page, now you will understand what they are talking about. This kind of is like a joke, but each one of these caret A and stuff, they are actually control characters. If you are a C programmer, you might have seen these. I'm not a C programmer, so I don't really see these. But also you see these kind of things in Emacs, especially the caret M. So if you understand ASCII, you read this, you see different notation, then you get, next time you see it, you understand it. Okay, let's read the comments. So how many people are watching? Let's see, 6 people. Okay, that's good. So WebDog, so Isaac says, oh, thank you. Okay, WebDog says, I spent like 2 weeks trying. Okay, Isaac says, I just learned home row for dvorak. So Isaac says, I had the problem of Chinese characters in org tables being too wide or something, and it messed up the org table. I'm not sure how to fix that, and I don't know if that's something can be fixed. Yeah, because you see, English characters are, Chinese characters are so-called too full width. Okay, this concept. Okay, if you go to the Unicode page, and if you go to full width here, you see, normally Chinese characters is more or less 2 characters width of English alphabet. So when you have Chinese and English mixed together, they don't look good, in the sense that typically if you have Chinese, every character is aligned. Your page becomes a grid. But as soon as you have some English, then it's not aligned anymore. So for some people, that's an issue. That's an eyesore. So Unicode created this. In Asia, you have this concept of full width characters, which is English characters. But each character actually takes twice as much space as the the normal English characters. They are like fixed width, but taking twice as long. It looks like this. So these are using full width characters. So in Ogmod you could use this, but it's probably not a good solution, because if you use this, then everything will be aligned. But however, English becomes ugly because usually you don't want to read English like that. But anyway, so WebDog says started to explain what I mean, but I just wrote the Emacs list instead. So okay, so maybe let's look at that. So anything else? Let's copy that. So go here, open a new buffer, paste it, set it to xah list mod, and delete that. And okay, you see, here's an interesting thing. When you copy things from Twitter and stuff, you will get these invisible characters. You see where my cursor is? Right there. Becomes a line. Now look, watch. I call describe char. Okay, describe char. It tells me that I have a zero width space. This happens on Twitter, okay, on Twitter or other social network, or on YouTube, Google Pages, because when you copy something, actually they use things like zero width space. Usually you don't want those. Characters are very annoying, and and usually they are hidden, so you normally don't see it. So I have written a command that takes them out. So look at the left panel. I'm going to call the command. So this is a command. So that's xah replace invisible char. And okay, I press enter. Oops. Okay, so let's do it again. Okay, so it's asking me, do I want to replace or not? I say yes, yes. Okay, so those characters are gone. You see. So if you like that command, you can use it. That command is this one, xah replace invisible chars, and you can find it in this URL. Let's go look at it. Okay, so it tries to find all these characters: zero with no break space, zero with space, right to left mark, things like that. Those characters are very annoying. And they are part of Unicode, like we talked about. They are invisible characters. So okay, so let's look at this list code. Let's see what it does. It's kind of oh, that's just one function. Let's just add space and press tab key. So define copy next command output. Copy kill the output of a unary function given. Unary function. Okay. Command for function name. Okay. Kill new condition command. So kill new basically delete the text but put it in a clipboard, in a kill ring. So kill new condition. So if f is a command, then execute. So call the command. Okay. So if it's not command, just call that. Oh, okay. Okay, I guess I know what you're doing. Yeah, so you want to call a command, and for its output you want to put it into the kill ring. So, but I'm not sure this will. I mean, it's great. Well, it's great, but I'm not sure it's gonna work 100% because buffer file name. Okay, yeah, I guess it works. And you have buffer file name in clipboard. Yeah, I guess it will. I mean, yeah, it's great. I mean, yeah, that's a good thing about Emacs, and Emacs is, when you have some issues, just create a command. That's what I do. Then it solves your problem. It's a great thing. So that's a great thing to. That's why you want to learn Emacs list. It's quite useful. So I think that's it for today. Let's see, 7 people watching. So anyone else, guys, pop up and say something. So I think that will be it. 17 minutes talking. Let me relax and have my drink. So what else? What else, guys? So let's see, green deck. So green deck is green deck. Is it 8 o'clock in the morning? Isaac is in California, I think. Mook Deacon. Where are you from, Mook? Much. How do you pronounce that? And the web dog. Oh, I forgot where you're from, web dog. Okay, guys, say something. Say something. So let's look at myself. Okay, in closing, let's listen to. Let's close that. Let's listen to this great song of Kazakhstan. Hey, Wansen. Just a second. Music. Wenshan. What do you think about Julian Assange? I think he's a great guy. Oh my God, this is a political topic. This topic is gonna get us banned. Thanks. Hey, Jan Christopher. Hey, great to see you. So Julian Assange, I think he's a great guy. He. So if you guys, oh, let's try that. Let me, yeah. So let's, he's a Emacs user. Did you guys know? Let me show you. He wrote a Emacs package back in Julian Assange. Oops, that's not the one here. Okay, he's got several articles. So Richard Stallman went and met him back in 2013. He's in the kind of like imprisoned in the Ecuador embassy in United Kingdom since 2012, I think. And Richard Stallman went and visited him, and they took a picture together. And Julian Assange is an Emacs user. He wrote a Emacs package for manipulating Windows, frames, buffers, back in 1998 or before. So you can see that people, special thanks to Julian Assange for his changed Windows intuitively.el. So he wrote that package. And another credit, so another evidence you can. This is the same Julian Assange as some people question is that the same Julian Assange? Yes, it is. So yeah, it's a sad story. So he, to me, okay. He shows disclose what the government is doing, nasty things basically. He disclose that to the people. And so back in 2000s, he was the enemy of U.S. conservatives, because he exposed something about Iraq war, where U.S. military just kill people, basically. But now he is hated by U.S. Democrats because, because he exposed Hillary Clinton's, evil deeds. So and the theft. So he went to Ecuador, to escape. Supposedly he raped. He's under rape charges. So what are the charges actually? I'm not gonna talk about it here, but you can, I have an article here. I think. Anyway, if you search my article, you might see it. I just tweeted it, in my Twitter recently. So anyway, yeah, and he's in a bad shape now because he haven't seen the sun for like 7 years. That's serious. If you cannot see the sun, I mean, even in prison, you have like every day you go out and walk for 20 minutes or something. So yeah, but the thing is, the Ecuador, the president has changed, and there's a corruption, and if you are U.S. government or whatever, you can say, hey, we give you, 10 billions or something, you do this as for us, and they are, so it's in a bad situation. So thank you guys. That's it for today. I'll see you. Hopefully, see you tomorrow. And if you like my work, yeah, let me say this. If you like my work, I got Patreon and Amazon, and PayPal. You know, you can put your money, for support. Thank you guys. I'll see you.